There's Bambi. Let's give this a shot. Open up to this part of the section. We are going to look at how we dealt with inequalities on Friday, and we're going to go just one step further. So this is guidelines for nonlinear. So for example, you might have x squared. You might have x plus 1 over x minus 3. Anything that's not just to the first power, that's what we want to look at. And the first step is we move all terms to one side, or set equal to 0. So, for example, for A, I would never expect that you would solve this the way I'm going to right now. I would expect you would graph it and do it the easy way. However, in order to get you able to do these type of problems, I want to show you an easy one to start with, okay? So, the second step is to factor. Does x squared plus 2x minus 8 factor? X plus 4, x minus 2. Less than 0. Things don't always factor. For example, let's say you had x squared plus 1. Does that factor? No, it doesn't. In fact, there's something we know about x squared plus 1. Is x squared plus 1 always positive, or is it always negative? If you square a number, it's going to become positive, right? And then add 1, it'll still be positive. So something like this doesn't factor, but it is always positive. So that's something we need to keep in mind. Also, if you factor out a negative, you need to be careful what you do with that. So those are things we got to be careful of as we examine these type of problems. Third step is we set up the interval for the top equal to 0 and for the bottom. Now there is no denominator here, so where is the top equal to 0? For what values? Negative 4 and 2? Set up my intervals on my number line. Now with my interval, I'm going to make a table. My table has columns, and it has rows. The columns are equal to number of solutions plus 1, and the rows is equal to the number of factors. Let me help you out here. I want to figure out how to divide this into columns. How many solutions are there for the top and bottom? 2. So how many columns will I have? 1 more, 3. These are 2 solutions. I'll have 3 columns. So you see my 3 columns. The number of rows is equal to the number of factors. How many parts did this factor into? 2. So I have 2 rows. Put the x plus 4 on one, put the x minus 2 on the other. This is my work. This is my chart. We'll do this 4 times, and you'll get how to do it by the time we get done with it. Okay. I make use of this now by solving. I check for positive and negative. That's how I solve it. We're going to plug in some numbers and test for positive and negative values. What value to the left of negative 4 would you like to plug in? We'll choose negative 5. How about between negative 4 and 2? 0 is a good number. How about to the right of 2? 3, 4. Somebody chose 508 a couple hours ago. That's fine. Whatever you want. So we plug in these values. Negative 5 plus 4. Is that a positive value or a negative value? Negative. And negative 5 minus 2? Negative. Let's plug in 0. 0 plus 4? 0 minus 2? 3 plus 4? 3 minus 2? Now we're going to multiply down because we multiply the factors together and they will tell us the result. A negative times a negative is a positive. Negative times a positive is a negative. And positive times a positive is a positive. Now again, I would never expect that you would solve this like that if you saw it on the test. You could solve it like we did on Friday by sketching a little graph. That's the way I do it. But I'm just showing you this so then you'll understand how to do C and D. Those are more complicated. So this question, is it asking where the graph is positive or where it's negative? Yeah, it says where is it less than 0? Less than 0. To be less than 0 means you are negative. And where is this negative? Between the two values of negative 4 and positive 2. Any questions? Question. You mean, do you have to sketch this kind of graph? No. Simply provide that and you're good to go. Okay, so let's do all those steps for B. What's the first step? Is it equal to 0? Yep, so we're good there. Second step, factor. What do you want to factor out? How about we factor out a negative? Because I'll show you a trick. I don't really care for the negative. I would like to get rid of it. If I divide both sides by a negative, I end up with just 2x squared. Whoop. Minus that 7x plus the 5, because you can see that the negatives cancel, right? Those will cancel and go away. And what is 0 divided by negative 1? 0. But if I divide both sides by a negative, what do I have to do? Switch sign. So you can get rid of your negatives. You just have to make sure you switch the sign in the process. Okay, so now it said equals 0. I got rid of my negative, and now we would like to factor it. So this does factor. I have a 2x and an x. Anybody see the factorization? Minus 5 minus 1. I have it factored. I now need to look at my solutions. I don't have a denominator, but I do have a numerator. So what are the solutions to 2x minus 5 and to x minus 1? Very good. 5 halves and 1. So I'm now going to make my chart. I have 2 solutions, so how many columns will I have? 3 columns. Got 1, and I'm going to write 5 halves is 2.5 because I think people understand that better. And I'm going to have 3 columns. How many factors do I have? 2. So I have 2 rows, 2x minus 5, and x minus 1. What is a number to the left of 1 you'd like to plug in? 0. How about between 1 and 2.5? And we'll go 3. Now we'll plug in and see what we get. 2 times 0 minus 5, positive and negative? Negative. 0 minus 1? My smartboard's being dumb. Yep, you'll get 2 negatives. There we go. If we plug in 2, 2 times 2 minus 5, negative, 2 minus 1, and 2 times 3 minus 5. Positive and positive. Do you multiply across or do you multiply down? Multiply down. Negative times a negative is a positive. Negative times a positive is a negative. Positive times a positive is a positive. Are we trying to answer where this thing is positive or where it's negative? Yeah, look at your original equation. It says where is it less than or equal to 0, but when you divided off the negative, you changed it. So you need to go with the one you changed it to. So we're going to look at it right here. The question is, where is it positive? Because it's greater than or equal to 0. So therefore, we're looking at the positive solutions. And it's positive or equal to 0 over there and over here. So you can see from negative infinity to 1 unioned with 5 halves or 2.5 to infinity. Why did I have the bracket on that one? Yep, because you got the equal sign. What do you think? Get how to set up the table? That was the #1 question people had last year, but I didn't tell them this. I didn't tell them how to make the number of columns or rows. I figured that they would know how to do it. And half of them did, but half of them didn't. So, all right. So let's try ones that are much more interesting. Those are kind of boring. These are really exciting. If you're feeling tired right now, trust me, this will definitely wake you up. Oh, you caught my sarcasm. Okay. Well, let's pretend like you're taking a test on this now, like Mr. Gens said. Okay, pop quiz. So, you have to identify the first step. What do I do first? Equal to 0. So I got 4x over 2x plus 3 minus 2 is greater than 0. Guys, can I change the problem? Because this will help clarify something. Let's put an equal sign underneath there. In the end, you'll be happy we did that. Let's change it so it could be equal to. You're going to see something that really stands out. Okay, I got to make it in one fraction, so what do I need to find? Common denominator is very good. 4x over 2x plus 3 minus 2 times 2x plus 3 over 2x plus 3 is greater than or equal to 0. If I distribute the 2 through, I get a 4x and a positive 6. So I got to have 4x minus 4x plus 6. What am I going to end up with? But I got to distribute the negative 2, right? So therefore I'll have negative 6 over 2x plus 3. Do you like the negative? I don't. Let's get rid of it. Let's multiply both sides by a negative. That'll change this to positive. I need to switch the sign. Okay, 6 over 2x plus 3 is a very interesting graph. And I know you want to know what it looks like, but we don't know right now. You could graph on your calculator. We'll do it in a little bit. But the fact is I can't teach you how to graph it right now. We have to learn more about Chapter 3 and stuff like that. So we'll get to that in a while. But right now, I go right back to the original problem that tells me how to handle these. I go right back to the original problem that says... So touchy. Okay. It says that I need to... set up the interval for the top equal to 0 and the bottom equal to 0. Because if you notice, this doesn't factor at all. It doesn't factor at all. Can you factor 6? I guess you could raise 2 times 3, but that doesn't help you at all. Can you factor 2x plus 3? No. So what we need to do is we need to look at these pieces. Where is the top equal to 0? Is 6 ever equal to 0? No. So I have no solution for the top. How about the bottom? 2x plus 3 equals 0. Is there a solution there? What is it? Negative 3 halves. So if I have one solution, how many columns will I have? Just 2. How many parts do I have in the top? How many factors do I have in the top? I've got just one. It would be positive 6. How many do I have in the bottom? Just one. 2x plus 3. If it didn't factor, I take the whole thing at the top and the whole thing at the bottom. I plug them right in there. Now, what number to the left of negative 3 halves would you like to plug in? Negative 2. And to the right of negative 3 halves? 0. The 6 sometimes confuses people. That's why I plugged it in there, okay? If you got the 6, can 6 ever be negative? No, it's positive. Is there anywhere to plug the negative 2 in for? No. So for the 6, it's just always positive. Doesn't matter what the other value is, that's always going to be positive. But I have 2x plus 3. If you plug in negative 2 to 2x plus 3, do you get a positive value or a negative value? Negative. If you plug in 0, you get positive. Positive times a negative is a, and a positive times a positive is a. Is this problem asking me for where it's positive or where it's negative? Can it be equal? Yes. So a lot of times when people set this up, then they look at the negative spot and they say negative infinity to negative 3 halves. Is that correct? They put that bracket around there. There's just a small exception, you guys. A small exception, okay? Here's what I need you to do. You either need to take out your calculator or you need to watch mine. One of the two, okay? I'm going to type in 6 divided by 2x plus 3, and we're going to get a look at that graph. And you're going to see what happens at this negative 3 halves spot. Okay? I'll wait. If you're following along, I'll wait till you type that in. I'll give you a second here. So you want to type it in just like that. And make sure we're all looking in the same window. You can press zoom and then 6 for a standard viewing window, and you should get this shape. Now, if you have, let's see, Carissa, you have a TI-84, right? You don't have that line up and down the middle, do you? Okay, mine's an 83. My calculator is not smart enough. It puts this line down the middle. That's called an asymptote. Asymptotes are where crazy things happen on graphs, and it's actually an imaginary line. It doesn't actually exist. We don't actually draw that line when we provide the graph. But here's why it happens. If you plug in negative 3 halves, what are you going to get in the denominator? What's 2 times negative 3? Negative 6 divided by 2. Negative 3 plus 3. 0. Can you divide by 0? No, you can never divide by 0. It's not allowed. This kind of stuff happens when you divide by 0. The graph goes all wonky. Is that a good word? Wonky? Do they use that today? Yeah. Is there a text for wonky? No. All right. It goes all crazy. It just has this erratic behavior. So that's what we got to be careful of. So the question is, can you include negative 3 halves as part of the solution set? Even though there's an equal sign there, you can't include something that would give you 0 in the denominator. So I make this one subtle change. Got to be careful. If it was negative 3 halves in the numerator, you'd be all right. But if it's in the denominator, you're in trouble. So you would see that example because you're going to have one in your homework. You never have to graph it. I just wanted you to understand that if you could come up with 0 in the denominator, you got to be careful of that value. You got to be careful of it. You just look to see if you're trying to include the denominator. If you're trying to include a spot where the denominator could be equal to 0, carve it off. That's a small little part, okay? All right, you're doing very well. One last problem, then you'll have time to work. This one should hopefully tie it all together for you if you don't see all of it right now. X over x plus 1 is less than 3x. What's my first step? Good. So x over x plus 1 minus 3x over 1 is less than 0. What do I have to find? Multiply top and bottom by. You get x minus 3x squared minus 3x all over x plus 1. What can you combine together in the numerator? The x and the negative 3x. So I have negative 3x squared minus 2x over x plus 1 is less than 0. It's all written as one fraction. It's set equal to 0. Second step is to factor. What can you factor out of the top? A negative x. Negative x times 3x plus 2 over x plus 1. Do you like the negative? I don't. Get rid of it. Multiply both sides by a negative. That switches the sign. Excellent. I now set up my interval. I look to where the top is equal to 0 and where the bottom is equal to 0. What would give you 0 here? 0. What would give you 0 here? Negative 2/3. What would give you 0 down here? Negative 1. So how many total solutions do I have? 3. How many columns will I have? 4. Whoop. Guess we're going to start at negative 1. How many factors are there? 3. 1, 2, and 3. X, 3x plus 2, x plus 1. What number to the left of negative 1 do you want to plug in? Negative 2. Negative 1 and negative 0.66666. Negative 0.8. Negative 0.6666 and 0. Maybe negative 0.5. Say positive 1. You can choose whatever numbers you want. If you want to choose negative 4.2 instead of negative 0.5, go ahead. So long as it's between those two values. Now, so far I've been plugging them in top to bottom every time. If you'd rather go left to right, you could plug them in like that too. Look at how nice this one is. If I plug in negative 2, it's going to be negative. You can see it's going to be negative, 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 positive. Whatever the value, what you plug in is what you're going to get. Let's go to 3 halves plus 2. I'm sorry, 3x plus 2. 3 times negative 2 is negative 6 plus 2. Negative 4, so it's negative. 3 times negative 0.8 is negative 2.4 plus 2, negative 0.4. Very good. 3 times negative 0.5 is negative 1.5 plus 2, positive. And 3 times 1 plus 2, positive. Now let's go to the last one. Negative 2 plus 1, negative. Negative 0.8 plus 1, positive. Negative 0.5 plus 1, and 1 plus 1. Now do I multiply across or do I multiply up and down? Up and down. Negative times a negative times a negative. Negative times a negative times a positive. Negative times a positive times a positive. And positive times a positive times a positive. Do you see the pattern? Not always. You see the stairway look here? It's not always going to happen like that. Most of the time it will. Most of the time, but not all the time. I could give you if we just change this on bottom here to squared, then it'd be different. Okay, so there are ways that you can change that so it doesn't work out, so it's not always predictable. But okay, are we asking where this thing is greater than 0 or less than 0? Greater than 0. So we're wondering where it's positive. That's the question, and we know where it's positive. It's positive in this area, and it's positive over here. And that looks like from -1 to -2/3 unioned with 0 to infinity. I showed the other classes the union symbol today. They didn't like it very much. But they got over it. Last thing, I just want to show you the graph of this so you can see how cool it is. I know you're going to like it. If I type it in, x times parentheses 3x plus 2, and I divide by x plus 1, and I go to my graph, look at the graph. Now, are you wondering where this graph is above the x-axis or below the x-axis? Above, because it's positive. Is it above or below right here? Below. So if you look at this area over here, and I'll zoom as a box so we can see a little bit more what's happening, because I want to show you guys what we solved for. It's fairly complicated. I mean, this isn't a problem that you could give just anybody and have them be able to solve. And we did it in the course of probably 4.5 minutes. Look at the graph. Here it is. Right here in my finger is the graph positive or negative. Positive. That's the -1 to the -2/3 spot. How about here, positive or negative? That's the -2/3 to 0 spot. And then over here, that's from 0 to infinity. So we figured that out like that. And there'll be a time where you'll know how to actually graph those equations, which is pretty neat. So all I have for you guys today. Tomorrow I'll show you an example like problem number 7 in your take-home test. Remember, that's due on Wednesday. And today, all I want you to do is these 3 problems, and the first one's already set equal to 0, and it's already factored. The second one is already set equal to 0, and you just have to factor out a positive 2. The third one, number 41, is a little bit more like the ones we tried at the end. But I'd like you to practice that right away and see how that goes. Question? Yes, just add to the 1.7. Just add right to it. Just continue to add. Okay? So you have 15 minutes. I will answer questions you guys have and come around and help you.